we need to talk more about measured quantities. We do a lot of measuring in everyday life, and we do a lot of measuring in chemistry and physical science. So every time you measure something, you have the numbers part. Let me pull up my pen here. You have the numbers part, so x point x, 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 that's my numbers part. And then you also have the units part. Okay, so that we call this units, sometimes we call that the label. Like 3.59 inches, that sort of thing. Now, the way you reveal or list the number part actually is important, and that's what we're going to talk about here. There's this important aspect of evaluating the number part of a measured quantity and what we say counting significant figures. So significant figures are a way somebody relayed to you something important about the measuring device. So, for instance, if somebody tells you they're measuring mass and they say it's 7.5 grams, but what if they say it's 7.5692 grams? Do you buy this, that if they can have a balance that gives me out to that nearest part of a gram, that is it's a more detailed measurement, right? So whenever you measure a quantity, there's these two aspects to how you report what number you report. So for instance, there's how accurate is the number you reported to what we call the true or the accepted value. The other part of whenever we go ahead and measure something and then go ahead and report an answer as a measured quantity, how reproducible is that measurement? And that's actually precision. A good way to kind of look at accuracy and precision is using a dartboard. So of course, if you play darts, and I don't, my brother does, but if you play darts, you're supposed to try to get it right here in the bullseye. Try to get your darts there. So if that is the true value, that's the true position. Can you see where, with regard to being accurate, these darts are not accurate, okay? And the other thing, so they're not accurate, they're not in the bullseye. The other thing is, can you see the spread here? I mean, they're like all over the place. Again, I'm not a dart thrower, but one of the things you, I think, work on is, can you place your dart at the same location every time? So that scatter is about the precision. So we say it has poor accuracy because it's not in the bullseye, and it has poor precision because there's a lot of scatter. So here we have somebody that has good precision. Good precision. Why? Because it's nice and tight. But notice that the center of that is not in the bullseye, so they're not very accurate. So that's how that kind of works. So poor accuracy, good precision. And then the last example I have here for you is we have darts that are nice and tight, so they have good precision, good reproducibility. And actually, sometimes when we measure things, there is a question, can we keep getting the same answer? That's precision. And then good accuracy. They're like right on the nose. So error, if you're off a little bit, is associated with being off from a known or a true value. So error is associated with accuracy, how far you are from the true value. And uncertainty is kind of that wiggle in, I call it wiggle, in the number that you reported. So for instance, we're going to do some examples coming up, but if I go back to your I'll go 2.5 grams, okay? Usually that means that your scale goes out to the nearest tenth of a gram, and oftentimes we'll call it a tolerance. Sometimes we'll say that it's plus or minus 0.1 grams. So that's kind of that's the uncertainty in that measurement. And that's associated with precision. We will and we can look at error throughout the semester. Sometimes, the only way you can look at error, by the way, is if you know a value, the best value. Sometimes it's what we call a theoretical value or a known. Okay, so this is theoretical / known. Okay, if we know the value, then we can actually look at our measured quantity and do just a difference and see how off we are. Okay, that's one way to look at error. Another way to look at error is what we call relative error or relative uncertainty. And then what you do is you basically take your difference. Oops, sorry, go back. No, that's right. You take your difference that you got from, let's see, experimental, that's what you got, minus actual, okay, and you divide that by actual. Sometimes actual is theoretical. And if you multiply it by 100%, you have what we call percent relative error. What's it doing here? Okay. All right. Now,